Have you ever just stopped and wondered, why do we keep building robots that look like us? I mean, of all the possible designs, we seem to be obsessed with the human form. Well, let's get into the incredible story of the humanoid robot.
You know, this quote from tech pioneer Nolan Bushnell, it just nails it, right? For decades, we've had this collective dream of a future full of robots, all driven by this amazing feeling of what could be possible.
And that really brings us to the big question for this whole explainer. From science fiction comics to the most advanced labs on Earth, what is the real reason we're so hooked on making them in our own image?
All right, so to figure that out, we're going to take a quick journey. We'll start with where the dream came from, then get into the nuts and bolts of engineering, see the mind-blowing progress they've made, check out where they're being used today, and then we'll take a little peek into our robotic future.
So, first up, the humanoid dream. And it's so key to get this. Before a single blueprint was drawn or a single screw was turned, the whole idea of a humanoid robot, it was born right here, in our collective imagination, in stories.
So, what was the actual spark that took this dream out of fiction and into the research lab? Well, you gotta go back to the 1960s. A professor named Ichiro Kato saw Japan's factories getting automated like crazy, and he asked a really simple but brilliant question. What's next? And the answer was obvious: the service industry. An entire part of our world built by humans for humans.
Okay, so we've got the dream, but turning that idea into a physical, walking, talking machine, well, that leads to our next section, engineering the human form. Because doing that, it was, and honestly it still is, a monumental challenge.
And once the race started, things moved incredibly fast. Think about it. In 1920, a play gives us the word robot. Just a couple decades later, Isaac Asimov gives us the 3 laws, a kind of ethical guide. Then, bam, 1966, Shaky proves a robot can actually think and reason about its actions. And just 7 years after that, it all comes together at Waseda University with the world's very first full-scale humanoid.
So let's just be super clear on what we're talking about here. A humanoid robot isn't just a machine that happens to look human for kicks. Its form has a very practical purpose: to fit into our world, to use the tools we use, and to navigate the spaces we live in.
And this brings us to our first major hero of the story, WABOT-1. I mean, you have to put yourself in 1973. This thing was just astonishing. It could talk in Japanese, it could measure distances with its camera eyes, it could walk on 2 legs, and it could grip and move objects. Get this, researchers figured it had the mental smarts of an 18-month-old child. What an incredible place to start. But, you know, out of all those amazing features, the single hardest problem to crack was something we do every day without a second thought: just walking. Yep. Achieving stable bipedal locomotion, basically walking on 2 legs without toppling over, has been one of the biggest challenges in robotics for decades. And that challenge leads us perfectly into our next section, from clunky to acrobatic. Because the progress we've made in solving that walking problem, and so much more, is just mind-blowing.
I mean, just look at this contrast. It says it all. On one side, you have the slow, careful, kind of shuffling walk of the early pioneers like WABOT-1. And on the other, you've got the incredible work of teams like Mark Raberts at Boston Dynamics with Atlas, a robot that can run, jump, and literally do backflips. The leap in what we call dynamic balance, the robot's ability to stay upright while moving and reacting, it's just staggering.
And a huge step on that journey was Honda's Osmo, which came on the scene back in 2000. For so many of us, Osmo was the first time a humanoid robot just looked fluid. It could walk, it could run, it could even go up and down stairs with this smoothness that just absolutely captivated the whole world. It really showed everyone what was possible.
So after all these decades of insane research and engineering, where's the payoff? Well, we're finally starting to see it. Let's take a look at where these robots are actually being put to work in our world.
And here we are back at the big question. Why the human form? The answer is actually really simple. We build them in our image, so they can work in a world built for us. They can climb our stairs, open our doors, and use our tools, all without us having to completely redesign our entire world just for them.
And we're seeing this play out in some really practical ways. Humanoids are being designed for everything from helping with housework and nursing care to being companions, like SoftBank's Pepper, which can actually recognize human emotions. And in medicine, you've got these incredible patient simulators like the Dentoroid that help train new dentists by acting just like a real person would. And it goes way beyond that.
The same core ideas of perception, of navigating the world, are critical for things like self-driving cars and delivery drones. And what about space? Yep, humanoids are being designed to go up there and help astronauts with really dangerous tasks, like construction and repairs on the Moon or the International Space Station.
They're also becoming these powerful tools for good. You've got robots like Neo that can tutor kids with these personalized, totally non-judgmental lessons. And in a disaster zone, a humanoid robot can go into a place that's too hazardous for people and operate the same equipment a human would, keeping rescuers safe.
So, all of this leads us to our final section. What does our robotic future actually look like? What's the end game for all this innovation?
The ultimate vision here isn't about replacement, not at all. It's about collaboration. It's a future where humanoid robots can work right alongside us, like natural partners, helping out in our homes, at our jobs, and in our communities, just making our lives safer and better. And that kind of leaves us with one final fascinating question to chew on. As we keep building these incredible machines in our own image, making them more and more capable, what do you think this journey of creating them is ultimately going to teach us about ourselves?